Hi everybody, sumchief here. This video is about matrices and the inverse of a matrix, and also to prove that your calculation is correct when you've found the inverse of the matrix. And after that, I'm going to show you how to put all this information into LaTeX and display it as a PDF output. So first of all, onto the matrix. So we've got matrix A, which we calculated in our last video. This follows on from that last video. Matrix A is 3, 5, 11 and 21, and we saw to calculate the determinant is AD minus BC. So if matrix A is like this, A, B, C, D with those variables, the matrix is A times D minus B times C. So here we've got 3 times 21 minus 5 times 11. So I've written that down here for you, highlight it up with the magnifier. 63 minus 55 equals 8. That's pretty straightforward stuff. So we did that in the previous video, just further confirmation that for you if you didn't see it. So now the inverse of a matrix. So the matrix A, which is here, is in capital A, but the inverse, pretty similar to what you would write in normal algebra, which is capital A to the power of minus 1, you could call, or A minus 1. That equals 1 divided by the determinant, and then matrix, which is broken up into A, B, C, D like this way. What happens is the A and the D value, you flip them round. So on the diagonal there, those ones, the A and D are flipped, and the B and C stay in the same place, but the signs are flipped. So basically the easy way to remember it is the negative diagonal, D, A and D, they just flip places, where the positive diagonal, B and C, stay where they are, positive staying where they are, but they become negative values. So positive gradient, if you want to think it like that, positive gradient becomes your negative values. So that's an easy way to remember it. So now what we've got to do now is just plug in basically our values into what we have here. So we've got D, A, minus B, minus C, which is our matrix A. The matrix A is 3, 21, 5 and 11. So the 21 and the 3 will switch places, and the 5 and 11 will just stay where they are but switch signs. We calculated the determinant, which is here, which is 8. So 1 over the determinant, which is 8, and then now we're going to just put these in the right place. So 1 over A times the matrix A. So we've got that here. So now we've got our variables in there. 3 and 21, 5 and 11. So now, let that back down, put all the proper variables in there for the inverse. 1 over 8, which is our determinant. The 3 and the 21 have changed places. The 5 and the 11 have changed signs. So now it's just basically like a scalar multiple. So 1 over 8 being the scalar, and then you multiply that by all the numbers inside the matrix. So 21 times an eighth is 21 over 8. Minus 5 times an eighth is minus 5 over 8. Same with minus 11, and the same with plus 3. So our inverse of our matrix is 21 over 8, minus 5 over 8, minus 11 over 8, and 3 over 8. Now these look like crazy calculations. I think like, doesn't seem like you're going right here. There's a way you can check it. So what you can do is you can get your inverse matrix, multiply it by your original matrix, and you'll always end up with the identity matrix. Now the identity matrix is 1, 0, 0, 1. So let's just go ahead and prove that. So I've got the calculations here. So to prove an inverse is correct, multiply by the original. A times A minus 1 equals I. I is the universal standard notation for the inverse matrix. So 3, 5, 11, 21 times by 21 over 8 minus 5 over 8 minus 11 over 8 and 3 over 8. So using our matrix multiplication formula, which we showed in the previous video, we go 3 times 21 over 8 plus 5 times minus 11 over 8, which gives us this one here, top left. Top right will give us 3 times minus 5 over 8 plus 5 times 3 divided by 8. So that gives us this one here. Then bottom left, 11 times 21 over 8 plus 21 minus 11 over 8. That's this one here. And then bottom right, 11 times minus 5 over 8 plus 21 times 3 over 8. So that's that one there. And then if you do all the calculations here, 3 times 21 is 63 over 8. 5 times minus 11 is minus 55. So it's basically 63 minus 55 is 8 over 8, which gives us our 1. This one here, 3 times minus 5 is minus 15. 5 times 3 is plus 15. So minus 15 plus 15 is 0. 0 over 8 gives us our 0. This one here should be the same again. 11 times 21, 231. 21 times minus 11, minus 231. 231 minus 231, 0. That gives us a 0. Basically same again here. 11 times minus 5, minus 55, plus 21 times 3 is 63. And then divided by 8, minus 55 plus 63 is 8 over 8. That gives us our 1. And then we proved there that we got the correct answer. So we can be confident that our inverse matrix is as we described it here. 21 over 8 minus 5 over 8 minus 11 over 8 and 3 over 8. So there you go, we proved it. So now looking into LaTeX, how we program this in. So as always, start off with your document, set up your document class. That's on this line here. So we got that there. So A4 paper, 10-point article. So I'm going to make a PDF output. And then got all my packages that I use. I've got some nice packages here, great for mathematics. And then I set up the page, which is on here. That's good. And this is the LaTeX stuff from the previous video, which you'll find in the description below. And then here is the LaTeX code I used for doing the inverse matrix. So you'll see here, open up the maths mode, backslash square braces. You'll see when I go along the square braces that the corresponding closure of these braces flashes orange. So you'll see there, as I keep going backwards and forwards, you'll see it flash. If you look on the bottom one, which is here, the first one also flashes. So that sets that up there. So you know that's the one corresponding. So to set up, to display the matrix, I've gone for backslash text bold format A. So that gives me a capital A in bold letters, equals, and then the matrix I've gone for backslash left parenthesis open. That gives me the big bracket, and then begin array. That starts off the matrix, and then in curly braces CC. That gives me 2 rows. If I'd have put 4 C's or 5 C's, that gives me 5 rows. And then for each one here, I've got 3 ampersand 5 and 11 ampersand 21. That gives me 2 lines as well. So if we look at that, that's my first entry into this document here. So A equals 3, 5, 11, 21. That's that bit there. Go back straight into the LaTeX. So you can see what that is. Then close the maths mode. Now I'm in text mode to write the determinant is, and then to go into maths mode here, I chose the $sign because I want it all on one line, and AD minus BC, so it looks like mathematical language. And then I've gone for double backslash, which means then I start a new line. So then I display the next matrix, which is similar again, which is ABCD, which I've got as for the inputs for that one, which gives me this matrix here. That's how I've got that matrix in. And you see here the determinant is in text mode, which is nice. And then AD minus BC has got a slight italic slant on it, which is great because that's in mathematical mode. So you can see that's, I'm not trying to write anything now, I'm just trying to talk in maths language. And then I've gone here 3 backslash times 21 minus 5. So here you'll see there, that's all in mathematical language. So the times, backslash times, that gives you a multiplication sign. So I've got 2 of them there. So you'll see that that one is this one here. So I've got the times there and a times there. That's how I got that one. So anything else I can show you? So now back into text mode, the inverse is shown as, which is on this line here, which I've got in here. The inverse is shown as. So let's go back, jump to source. Okay, so now for maths mode this time I've gone for begin align. So this then will align all the matrices so they align up to the ampersand that I nominate. So with this asterisk, that's what I get. So I've gone for text bold format A, and then because it's inverse, I've gone to the power of -1 in curly braces equals ampersand. So let's just show you what that does there. So that's what I've got here. A to the power of -1 equals, that's how I've got to that stage there. And then, and that lines everything up. And I've written in my determinant as a fraction. So this time I've gone for \frac. So frac, and then two sets of curly braces. I've got one here, which is in its own curly braces. And then this time here, to get the determinant, I've gone for \abs, which is like absolute value, which then gives you two straight bars either side of whatever you write in the curly braces. So because it's determinant, I've just gone to det for determinant. I put that in the curly braces, and that's what absolute value I'll have, or what in the absolute value kind of notation. But obviously it means the determinant. So that's the notation for determinant. And the whole thing is in the curly braces because it's still under the control of the frac control. So if you see that there we go. Look, you see that's all lining that up there. And then I've displayed my matrix. This shows you where the D and the -B, next line -C and A, that's gone there. So let's just show you where that is. So that's what we were just talking about there. So the two straight bars, as you can see here and here, either side of the determinant, and it's in a fraction, so that's good. So that's how we'd like to present that. And then the matrix there, which we've already gone through a few times already. Back into the textworks. So this time I've gone for a gap between each matrix, otherwise they tend to be squashed up a little bit. So I've gone for double \, which is here, and then a new line, and I've started basically progressing on, substituting in values for the formula that we started with. So that's got there. So you see again this first ampersand here after the equal sign, this one here is after the equal sign, and this one here is after the equal sign as well. So if you have a look there, all the equal signs are in a nice straight line, and that's by virtue of the begin align control. That's why all those are in a nice straight line, so that's good. And also you'll see here I've gone to put the capital A for the matrices. The next couple of lines I've done without it. I've just gone equals straight into equals, and then on my answer I've put the text bold format A to the power of -1 equals ampersand. And then you'll see here is missing, nothing there, but then it's appeared here, but it's still in a nice line. It hasn't affected this line of the equal signs. So without that begin align function, all these equal signs would all shuffle across and be in line here, and then move out back here at the end. So we look a little bit untidy. So that's a way of tidying that up. And then, as always, with the \green functions in the textworks, you have to end the align. So at the beginning here, I'll begin a line. Here, I'll end a line. And then again here, I've gone to prove the answer is correct. Pretty straightforward. Just go through it slowly for you so you can see what I've written there. So I'm in text mode. To prove an inverse is correct, multiply by the original. Then in maths mode again, simple maths mode with a $sign to show you what happens with the A times A minus 1. And then my matrices are inputted there, and times, I've got the multiplication sign here as well in between the matrices. So I've got a times sign there, you'll notice, on the matrices. So if I show you where that is, you can see where that is. So here I've got a multiplication sign in between a matrices. So that's always quite a nice little thing to have. So that's a nice little one for your toolbox there. So times in between the matrices. Then I've closed the maths mode, space, open maths mode again, filled in more variables, gone through everything, and this time done a nice little calculation here for the \left open square braces. So that's that one there, and you'll see it's flashing up over here with the right. So that will display my matrices there, and then got that one there, which is the second part of it. And you'll see I've done it again here. \left open curly, open straight braces, Then the same here, gone for \right straight braces. So you have your left and your right just to close off each time. Same again here, and same again here as well. And we've got it here as well. So I'll show you what that does. So that one there. So that's giving me these square braces. So there. So I've got parentheses for the matrix, which I've got here, but I've also got square braces. I just didn't want to have the same looking braces for the whole thing. It will look a bit untidy. So now you can clearly see that this is my calculation to give me my top left. And I'll put it in the square braces. And the same here for the top right, bottom left. And then just to finish off, I've displayed what the inverse matrix is here, 1 0 0 1, and then end enumerate, which I had at the beginning there, and then end document. So there we go. So that's how we do it. So that's inverse matrices and how to import into LaTeX. Okay, so thanks very much. Thanks for watching. Any questions, put in the comment box below, and as always, please remember to subscribe. Okay, thanks for watching.